Hello, today I'm going to show you how to solve a more step-ridden logarithmic equation problem. I'm not going to linger too much on the algebra aspects of this specific equation, but if you'd like me to make a new video on a more in-depth explanation, please comment down below. I encourage you to pause the video and try this one on your own before I proceed with the solution. Okay, so first thing that I notice, and I want you all to notice here, is that all of these logs have the same base b. Now we don't actually know what the base is, but the fact that they're all the same will help us tremendously in solving this equation. So another thing I notice is a lot of them have coefficients in front, well, 3 out of the 4 have coefficients in front of the log. Now, you may or may not know, but one of the properties of logs is that you can actually take this coefficient and put it as a power to the power of the logarithm. So, for example here, I can rewrite this as log base b of x squared, and vice versa. If I have log base b of x squared, I can rewrite that as 2 log base b of x. So I'm going to do that for all of the ones that I can, which is 3 out of the 4, except for this. That's excluding the last one there. So I'm going to rewrite all of them, putting the coefficient as an exponent on the power. And you'll see why that will help us. Alright, so 1 minus a squared plus log base b 1 plus a squared. Minus, I'm not doing anything with this one, I'm just rewriting it. Okay. So now that we have it rewritten, and what we can do here is, because on the right side of this equation, we can actually combine all 3 of these logs. Now, in order to sort of dissect this a little bit, you should look at it as we're combining these 2 first into 1 log, and then combining it with the 3rd log. So let me just rewrite this left side here. A property of logarithms is that when you have 2 logs being added together and they have the same base, you can actually rewrite it as 1 log, but multiplying their powers. So let's go ahead and rewrite that, and then for the 3rd one, I will get into that. So we can rewrite this log base b of 1 minus a squared plus log base b of 1 plus a squared as log base b of 1 minus a squared times 1 plus a squared. And as for the 3rd log, if we have this one big log here, when you're subtracting a log with the same base, it's actually the same as dividing this product of these 2 logs by this power of the 3rd log. So we can rewrite that as the product of those 2 logs divided by 1 minus a squared. So keep that in mind. Adding logs with the same base, you can rewrite it as 1 log and multiply their powers by each other, and subtracting a log with the same base is the same as dividing the powers by each other, dividing this power by this power. Now, another thing you may notice here is that we have 2 logs with the same base equal to each other. So we can basically set the powers equal to each other. Now keep in mind, if I were to have, say, a plus 1 here, I cannot set these powers equal to each other. they have to be one log with nothing else, no constants, no other terms after it. So keep that in mind because I do see that mistake a lot. So we can go ahead and get rid of these logs because they have the same base, and we can rewrite the powers equal to each other. So 1 minus a squared times 1 plus a squared all over 1 minus a, 1 divided by a minus a squared. Now, as you may or may not have noticed, all three of these factors here are squared, and we have a squared term on the left. So I'm going to take the square root of both sides, and in turn that will cancel out these squares. And we're almost to the finish line. Just a little more algebra, and we will be there. Okay, so let's rewrite this here. We just took the square root. 1 over a minus a. Okay. So now what I'm going to do is I'm going to FOIL this out, and you may have noticed that this is a difference of squares. So when you FOIL it out, you find that it is equal to 1 minus a squared. As for the denominator, I'm actually going to get a common denominator. So this is a implied a over 1. So I'm going to multiply this a times this another a, the numerator and the denominator, so that I can combine those two terms. That leaves me with 1 minus a squared over a. And now you can divide these two fractions. 1 minus a squared, there's an implied 1 there. I'll just write it, times the reciprocal of this, so it's a over 1 minus a squared. And lo and behold, these two factors cancel, and you are left with x equals a. And that is your simplified answer. Turn this whole mess of logarithms into this simple variable. Hope this video helped you, and let me know in the comments below if you would like more videos like this, or if you'd like more in-depth explanations or any other concepts you'd like to see. Thanks for watching.